Hello everyone. So welcome to my lecture video for exam P1. So I'm Dr. Wang. So in this video, we will check a problem from 41 to 55. Okay. So this problem 41 says we started two independent groups. So we have two independent groups. So each one have 10, right? 10 parties hold. Okay. So individual participates in the start drop out before the end of start is probably point 2. So here we have 10 people here, 10 people here. So some people will drop. So this drop is point 2, but some people will stay. So for each people, he can maybe drop or not drop. So we say the number drop is binomial distribution, right? So this is binomial. Like the n equal 10, and we can say like drop is 0.2, so stay 0.8. So what we want to find? Let's check this. What is the probability that at least 9 will stay, will complete? Okay, in one of the two groups, but not in both. Okay. So this means like maybe like here we will at least 9 or drop. We just focus on drop. Drop is less than 1, less than equal 1, right? Or maybe here drop is less than 1. But it is one of them, not both. Okay. So suppose we say the A, group B. So we have this case. So means like A this thing happen. Now for group A, this thing happen, but this one for B not happen. Or let's say here a little bit confused. Let's say for group A, so we say group A less than 1, but B will larger than 1. Or we can say the other one is A is B less than A larger than 1, B less than 1. Like this, right? So one of the two group is at least 9 stays, so means at most 1 drop. Okay, so these two probabilities same. So we just check this equal 2 times this. Yeah, 2 times this. We can forget this, right? Okay. So this say that group A, group B are independent. So there's two groups independent. So we can have this probability equal 2. So P we say like A, group A less than 1. Group B larger than 1. So group B larger than 1 is 1 minus group B less than 1. So group A less than 1 or group B less than 1, the same. Right? So we put this as X. So we let X equals this. P A less than 1. So we just need so this equals just 2x 1 minus x. So we just need to find x. So x equal, so this is the binomial distribution. So we say drop is 0.2. So those things happen at most one time among these 10 people. So this equal drop, no drop, right? No drop each one. So stays 0.8, right? And then one drop. Okay, from 10 choose 1 10. So one drop. And other one stay, right? So x just equals us. And for this one, let's see, we can 0.89, and so here's 0.8 plus 0.8 plus, so here's 2, right? Or 2.8. Okay, but anyway, so this is just the calculation. 2.8 multiply 0.9. 0.8, I'm sorry, 0.89. Okay. So we find this x thing, we find this probability. Okay, so for problem 42, for company A, so no claim is 60%, no claim. If one or more claims are made, the total claim amount is normal distribution with mean s and deviation s. If one or more claims are made, so the total claim amount. So this total claim amount, we don't this total claim amount. So no matter how many claims happen, right? So for company B, 70% chance no claim. Okay, and so then 30% claim, they have claim. So if they have claim, so this amount, suppose here we say there's a total claim amount is X. Here for company B's total claim amount is Y. Okay. So we assume that X, Y are independent. So what is the probability that the company B's total claim will exceed company A's total claim? Okay. So for company A, we have two cases: no claim, 0, or some claim. So for company A, same thing: no claim and a claim is Y. So company B's total claim is more than company A's claim. So we can say like this probably if this have some claim Y and this is 0, so so this is just okay. So we just Y larger than 0, right? So let's say so this case like Y. So for company company A, like we just put this like A equals 0, B equal Y. Okay, B not equal 0. So this case, right? And plus so A not 0, B also not 0, both of them not 0, but in this case like Y larger than X. Okay. So here A equals 0 is no claim. A equals 0, no claim is 0.4. So 0.4. So B have some claim. B have some claim. B have some claims 0.3, right? 70 chance. Oh, I'm sorry. 70 chance no claims. The 30% chance have claim. So here's A, company A, no claim. Company B have some claim, right? So plus, so for here, actually both of them have some claim. So both of them have claims. So don't forget that both of them have claims. So company A has a claim. So company A has a claims point. Oh, I made a mistake. Yeah, company A no claim is 0.6. Yeah, so here 0.6. Yeah, 0.6. So company A no claim. Company B has some claim, right? So and here company A has some claim, so 0.4, and company B also have some claim. Okay, so then when they both of them have some claim, so then you say y larger than x. We want to find this probability. Okay, so let's check this probability. So we say x follow this normal, y follow this normal. So x follow this normal. Mean is this. Standard deviation is this. And the y follow this normal. Mean is this. Standard deviation also this. Okay. So what is the probability for y larger than x? So we just change this as this probability. Y minus x larger than 0, or x minus y less than 0. Okay, maybe we just, so this doesn't matter. Let's see, I did put this. Okay, x minus y less than 0. Okay, yeah, so we need to find the distribution for x minus y. So x follows this normal, y follows this normal. So what is x minus y? So x minus y follow this normal. Mean is this minus this. Okay, but the standard deviation. So variance is equal to this variance plus that variance. So this standard deviation variance is equal to this square. This square plus this square. Then take a square root. Okay, so y x minus y is this normal. Okay, so we put this. So suppose this is z. Okay. Okay, so we see this z. So v or probability is just like z less than 0, right? So what is this z? Z follow this normal. Z follow this normal. Mean is 1000, and the standard deviation take 2000. The square outside, so 2000 let equal 2, right? So this is the distribution for z, so we can find the probability z less than 0. Okay, so this equal changing 0 to standard normal. So standard normal, let's say, maybe we should not use this z. So, but anyway, we use a. Okay, so standard normal, so this minus mu divided by sigma equal, like we prefer to use standard normal, use z. Okay, so we just use a little bit confusing for use this notation z. So z less than negative, so 100, 200, 1 over 2. So 1 over 2, okay, radical. So here just use calculate here. So we can find this probability. So use so now we can check the normal table, find this number like 1/2 radical 2. So check this. Okay. So for this problem, I got confused because I cannot understand this. Find the probability that there will be at least 4 months in which no accident occur before the 4th month, in which at least one or so. This sentence I got confused. So for this problem, for me, I just skip, okay, because I got confused for the sentence. Okay, so now for this one, those problems really clear. We want to find expected value, right? Expected payment for hospitalization. So we just check what is the payment. Okay, so it says pay 100 per day up to 3 days for hospitalization. So first day, second day, third day. No. So here we'll pay like 100, second day 100, third day 100, right? Then here for just pay 50. So 50. So pay how many days? 50, 50? Oh, this is like, let's say, so the number of days follow this distribution. We have this probability. So these days can be 1 day, 2 days, 3 days, 4 days, 5 days. Okay. So now let's say find payment. If 1 day, so let's say, so 1 day. Okay, but what we're talking about is total payment, right? If 1 day is thus, so 2 day actually 200, right? So here there's pay each day. So here don't got confused, each day pay. So here's 3 day total pay 300, 350, 400. Then the probability for this happen is like a probability P. So for this payment happen or pay just for 1 day, stay there for 1 day, 15 over 5, right? Then this is 4, so there's 3. Then okay, so expected value is very easy, right? So just equal this times this. So 100 multiply this, 200 multiply this, 300 multiply this. Okay. So for this calculation, we just say just forget the 15. So divided by 15, right? So here like 100 multiply 5 days, so 100 multiply 5, 500, and plus 800 plus 900, right? Okay, just like that. So problem 45, this is a continuous distribution. So what we want to find the expected value. So expected value equals this, right? So use the formula negative infinity to positive x if x dx. Okay, so in here x just from -2 to 4, but in density function we have absolute value. So we just split this into two parts. Let's say from -2 to 0. Saying here x. So if x is absolute value, so here's -x, right? So dx. So plus, so from 0 to 4. So here x times just x dx. So for this integration is very simple, right? So we can take a thing outside, so each one we can calculate easily. So that's equal 1/10. So here x squared is 1/3 x squared. So 1/3. So this minus this is 1/3 x 3 is 2/3. Negative 2/3 become 2/3. So here plus 10 1/3. So this is 4/3. Right? Okay. So here we say x equals this. We want to find expectation. So this x is the maximum of t and 2. So those x is just like, okay. So this x is t. So here from 0 to 2 is t, but the larger than t, larger than 2, t larger than 2, there's x equal 2, right? So this is x. So x, let's say maximum. Oh, no. Maximum of t2. T2. Oh, God, I'm wrong. So if t between 0 to 2, then x is 2. So if t larger than 2, then x is t. Okay. Right? So what is t? Okay, so there's t. The time t is exponential distribution mean 3. So we know t. Okay. Okay. So the t follow, let's say t follow this exponential distribution with mean is 3, so this lambda is 1/3. So we know there's a t follow this follow this distribution. So we want to find x. So x, okay, so x just according to definitions. So when t from 0 to 2, this x is 2. Okay. So then if x is lambda is negative lambda x dx. Okay. Then the function is just lambda is negative lambda x, right? So this is for discrete. No, this is for exponential distribution. Okay. So then plus. So when larger than 2, so from 2 to infinity, so this is equal t. Oh, we just use x. Okay, x lambda is negative lambda x dx. Okay. Okay, so this becomes just the integration problem. Okay, so for this part, for first part, we say this. So we for exponential distribution, we should remember the notation. This is just like 2 times the integration between 0 to 2. So this equal, first one equal 2 times the e lambda 0. So this 1 minus e lambda. So maybe a part of this formula again, like the probability between A and B is equal negative lambda A minus negative lambda B. So this is equal, so negative lambda is 1 over 3, 2. Okay, so this is the first one. Okay, so second one. So second one, so we can use integration by parts. But the good way is just to use this result. We say for exponential distribution, the mean equal 1 over lambda. Okay, so this 1 over lambda here equals 3. Okay. Okay, so here, so what is the x? So the x is from 0 to infinity. So here just from 2 to infinity. So I just changing a little bit. Let's say so here. If this x from 0 to infinity, so I know this integration, right? Equal 3. This is just the mean. But this is from 2 to infinity. So I just changing a little bit. Let's say I let x equal t plus 2. Or we just say x minus 2 equal t. So when x equal 2, t equals 0. So this integration just become from 0 to infinity. So this x is become 2 plus t plus 2, saying lambda e negative lambda. So the x t plus 2. Okay, dt. Okay, so we just use this for t lambda is negative lambda t equal 1 over lambda equals 3. Right? So for this one, so we need to just use this substitution. So here we split into 2 parts. One is 2, let's say, and first take this out, e negative lambda 2. Take this out. Okay, I have no enough space. But I just mention this. So take this e negative lambda 2 out. So this lambda is 1 over 3. Right? So take this out. Then this one become 2 parts. So here 0 in, so t lambda is negative lambda t dt. This part. And plus 2. So plus. So this part 2 lambda is negative lambda t. So this also I know the integration. Okay, this is 1. Yeah, this integration is 1. Okay. So here for this integration, so we need to use this scale. Okay, just use the use this given condition, using this information. So things follow exponential distribution. Okay. Okay, so for problem 47, it says some we buy insurance just against early fear. So the time from purchase until fear, so the time, so this x, that's t, or time, follow this exponential distribution. Exponential distribution, mean is 10. Okay. Okay, so the payment is, let's say, so if fair in the first year they will pay x, and we'll pay, okay, so second year we'll pay 0.5x, or third year 0.56. If let's say if fear happen here, pay x, happen here pay 0.5, happen here also pay 0.5. Okay, so if fear occur after the first 3 years, then no payment. So here pay 0. So here pay 0. So because there's payment 0.5x, 0.5x same, so we can put them together. So when the times from 0 to 1 pay x, from 1 to 3 just pay 0.5x. So after 3 pay 0. Okay. So the questions we want to find x, right? At what level must x be if the expected payment is to be 1,000? So we just find expected payment. Okay, so expected payment equal, so pay x. So this is the probability t between 0 to 1. Okay, and the payment is 0.5x, so t between 2 to 3. Right? So we just let this equal 1,000. So here we just need to find those probabilities. So this probability, so we just check, okay, so we let this equal 1,000 equal x. So this probability is, let's say, this probability is equal 1 minus negative lambda. So here lambda 1 over 10. 1 over 10 times 1 is 1 over 10. Okay. So plus 0.5x. So here is negative 1 over 10 times 2, so 2 over 10 minus negative 3 over 10. Okay. Okay, so use calculator we can find those numbers, and then we can solve for x. Okay, so for problem 48 also we want to find expected benefit. So then we want to find what is the benefit is. Oh, like benefit for these policies, just the payment. Okay, so same story. Like, okay, so if fair from first year, they will pay 4,000. And second, so if fair in second year, so they will pay 3,000. Then 2,000, right? Then 1,000. Then here 0. Okay. Okay. So the probability, so let's say, So here, if the device has not failed by the beginning of the given year, the probability it will fail during that year is 0.4. Okay, so we say like here, not fail, good. So then at this first year will fail is 0.4. So this is 0.4. 0.4. So 0.4 is the probability for the first year will fail. Then second year, so second year is like not, so first year fails 0.4, so not fail is 0.6. So here is 0.6 means first year, okay, but second year fail 0.4, right? And then here, so third year is not fair is 0.6, 0.6, then 0.4. Okay, like this, right? So here 0.6, 3, 0.4. Like this. So those are probability. Okay, so we can find this expectation easily. So this equal first year. So this is multiply 0.4. So second year. So multiply the probability. Second year fail. Second year is 0.6. First year okay. Second year fail. Then plus third year fail. So this equal like 0.6 square, 0.4, right? So here, so continue then 100, then 0.63, then 0.4. Okay. Okay, so for this problem, also find expected payment for hospitalization. So how much they pay? And this problem okay, part of the same as we just discussed it. So let's say so it pay first day, day 1, day 2, like day 3, day 4, day 5. First day pay 100. Per day up to 100. Yeah, 100. Then here pay only difference pay 25 for each day of hospital. Always 25. But the number of days is only from 1 to 4. So this X number of days. So we just need that. So for expected payment, so total payment. So here's 100. First day 100. Second day, if you stay hospital for 2 days, 200. Yeah. 3 days 300. And 4 days, so 325. So 5 days 350. Okay. And then probability. So this is equal just 5 over 15. So here is 4 over 15, 3 over 15, 2 over 15, just 15. Okay, so now we can easily find the expectation. Just this multiply this, right? So first number, second number, multiply. Okay, so for this one, what we want to find is what is the expected amount paid to the company under this policy. So this is just find the expected value, okay, for payment. Okay, So let's say, so how much they should will pay. Okay, so the company just pay, let's say, the snowstorm. So it says they will pay nothing for the first one, pay 0. So let's say n is number of snowstorm. So 1 can be the number of snowstorm in a given year. Can be 1, can be 2, can be 3, right? Can be infinity. So payment is first time pay 0, second time they will pay so much for each one. So we just will pay this. So just pay one time. Yeah. Let's see. Say policy pay nothing for the first such snowstorm, and so much for each one thereafter. Okay. So if they have 3 total snowstorm, first one will not pay. So second 2 will pay. So here pay thus, right? So we find if the number here is k, how much they will pay? Pay thus multiply k minus 1, right? Okay. So now we want to find what is the probability that those things happen. That happen number n equal k. What is this probability? Okay, so this is the number of snowstorm for a Poisson distribution. The mean is 1.5. Okay, so we have this. We know n equal k is thus lambda k factorial e negative lambda, right? So because it's n for a Poisson distribution, and this is k actually can be from 0 to 1 to infinity, right? Okay, so now we want to find expectation, expected payment is thus, like says n equal k multiply the payment. So this equals, so we take this number outside. So payment is, let's use a summation. Payment is k minus 1. Right? Payment. Multiply the probability. Probability is thus lambda k factorial is negative lambda. So this lambda we know is 1.5. Yeah. Okay. So here actually from 1 to infinity. Okay. So here we need to find those integral as this summation. Okay. So here we should use so forget this 10,000. So we should use this information, Poisson distribution. So for Poisson distribution, we know thus. We know Poisson distribution. We know, suppose x for a Poisson. Then the x equal what? The x equal lambda, right? So we just use this. So what is x? So x equal this summation. Okay, k then lambda k factorial is negative lambda. So k start from 0 or start from 1. Okay, so we know this. So this equal lambda. So we just use this. Okay, so here we put these two parts equal k equal 1 to infinity, k times lambda k factorial is negative lambda, right? So minus lambda k factorial is negative lambda. So here k equal 1 to infinity. So for first summation, we know this just equal lambda. Okay. So what is second summation? Second summation is a summation of all probabilities. Like n equal k, summation of n equal k equal from 1 to infinity. So we know this k from 0 to infinity is 1. So this one we can say this is just the probability for. We also can write this as probability that n larger than just equals this, right? So we say larger than 0 is 1. So this equal 1 minus p n equals 0. Okay, so what is n equals 0? N equals 0 is a plug in n equals 0, k equals 0. K equals 0 just is negative lambda. Okay, so what is lambda? Lambda we already know is 1.5. So we say that this equal 1.5 minus 1 minus negative 1.5. Okay. Okay. So this number multiplied 10,000 is the expected value. Okay, so for this problem 51, we have this loss, annual loss, just x. This x have this density function. This density function. Okay. So, okay. So loss this, then to cover its loss, is the company purchase an insurance policy with annual deductible of 2. So we want to find the mean of what? Mean of their loss, mean of the x not paid by insurance policy. Not paid. Okay. Okay. So let's say, so this x, yeah, so deductible is 2. So if x here between 0 to 2, then the insurance company will pay nothing. So you should pay. You should pay all those damage, x, right? The company will pay 0. And if the x larger than 2, you need to pay 2. The company will pay x minus 2. So your payment is like this. Between 0 to 2, you need to pay all by yourself. So if loss larger than 2, you need to pay 2, right? So this is your this is you should pay. The company, the insurance company do not pay it. Okay, so this expectation is this equal. So when x between 0 to 2, you need to pay x, and the density function. Okay, density function x is 3.5. So put this number as k. Okay, and this x also larger than 0.6, not from 0, from 0.6. Okay, so we just put okay from 0.6, right? So then plus, so from 2 to infinity, you need to pay 2. So these 2 not paid by insurance company. So this just like that, like kx 3.5 dx. So for this integration, it is easy, right? This is, let's say, this one for example, this is a power function. Suppose this is k is constant, we already know. So this is 2.6. So here x negative 2.5 dx, right? So for example, for this one, so we can integrate it out as let's say negative 2.5 plus 1 is negative 1.5. So this equal, for this one is just k. So so 1.5. So x negative 1.5. So this equal so this equal 0.6. Let's say 1.5, negative 1.5. Yes. So minus 2, negative 1.5 power. Okay. So then just check this. So this is take a constant outside. So this is just x negative 3.5. So integration, just part is also easy. Okay. So for problem 52, so this policy have deductible of 2. Okay, so the damage, the loss can happen or not happen. So happen, the probability is this. So if this damage happen, the loss amount, so this amount in can be loss, can be 1, can be 2, can be 5, right? Yeah, so this n can be 1 and 2 and 5. Okay. Then we want to find net premium, or just find expectation for payment. Okay. Okay. So we say here, let's say no loss is such a chance is 95. So have loss, such a chance is 5, 0.005. If have loss, then loss amount in loss n can be 1, 2, 3, 4, 5, right? And the probability for loss is 1 or 2 or 3 or 5. It says is k times k is constant k times k times 1 over 1 times k and 1 over 2 times k. So 1 over 3 times k, 1 over 4 times k, so 1 over 5 times k. So this k we need to find. Okay, so we know all the probability equal 1 n equal 1 or 2 or 3 or 4 or 5, so those probabilities equal 1, so we can find the k. So let's say find the k first. So k, so we just add them up. 1 plus 1 over 2 plus 1 over 3 plus 1 over 4 plus 1 over 5. So this equal 1. So this is this k. Okay, k is equal so 1 over this number. Okay. Okay. So now we can find then we have a deductible. Right? So if loss is 1, payment. Yeah, so payment is quite a confusing thing. Payment is like here, if n equal 1, pay 0. If n equal 2, pay 0. Okay. If n equal 3, we'll pay 1, right? So and pay like this. Payment is this. Okay. So we want to check the expectation for payment. So is payment. So we can find is payment equal 1. So multiply the probability for payment equal 1. And so payment also don't forget. So if payment only this thing have loss, this, so you should multiply thus only 0.005 because 0.95 no payment, just 0. So and have payment, have loss, and have payment 1. So payment 1. So multiply probability is 1 over 3k. Okay. Plus, so payment equal 2. So probability is 1 over 4k. And payment is 3. So 3 is 1 over 5k. Okay. So this is the expected value for payment. Okay. Okay, so let's see. Yeah, so here we need to find the k first. From here, find the k, and from then plug in here. Okay, and multiply 0.005. So here we still have some calculation issue, right? Okay. So don't forget to multiply 0.005. Okay. So only in this thing, only in this case, this payment can happen. Okay. So this one, this is insurance company reimburse a loss up to benefit limit of 10. So have benefit have a limit. So this means that if a loss larger than 10, they will pay 10. The loss y follow this. That's the function. Okay. Okay, so we want to find expected payment under this policy. Okay, so let's check. So payment. So y is from 1 to infinity. Okay, so y larger than 1. So loss at least like 1. So deductible, benefit, so limited thing. So payment is just this, no deductible. So here pay y, here pay 10, right? Okay, so this expectation for payment equal, so from 1 to 10, the loss from 1 to 10 pay y, and that's the function. So we just plug in, okay, 2y3 so dy. So plus, if more than 10, then they pay 10, and probability 2y3 dy. So such a problem by now is quite simple, right? So let's say like this one, just like the power function integration, y negative 2 dy, and this one 20, yeah, 20. So this is y negative 3 dy. Okay, so for such integrations, very easy. Okay, so for problem 54, okay. So we have, so the policy have 1,000 deductible. They are insure an automobile. What's that? So they have this chance for partial damage, and this chance for total damage. So total damage means loss is 15,000, right? So for a partial damage, so this number, this damage is a random variable, can change, right? So this damage is density function thus. So we want to find expected equivalent payment. So we just check this, like, okay, so partial 004, partial damage is x, okay, and total damage 004. So total damage is thus. But we have 100 deductible. So here the payment is pay thus 1,000 deductible. But here payment, we need to check, okay, so if this x between 0 to 1, between 0 to 1,000 pay 0, they will pay 0, and then here will pay x minus 1,000, right? Okay, so we use 1,000 as a unit, so 1,000 just 1. So we know this expectation for payment is, so from 0 to 1 pay 0, yeah, and from 1, okay, have partial payment, partial damage 004. Don't forget 004. So time thus. So time, if from x from 0 to 1, no pay, right? So if from 1 to, let's say, so the x, total x for 15, right? If from 1 to 15, they will pay x minus 1. Okay. So density function is this coefficient is thus negative x over 2. Okay, so dx. Okay, so this is for partial damage. Then for total damage, the total damage payment is easy. Payment is thus. Okay. Okay, so now our problem is how to calculate this. So this become math problem. How to find this integration. So maybe for this integration we have some trouble. This math problem. We need integration by parts. Okay. So, but anyway, like we want to simplify a little bit. At first, we take the coefficient outside 0.5003. Forget this. Like put this in front of. So, and we substitution x minus 1 equal t. We just make this integration easy. Okay. So then this integration becomes from 0 to 14, right? Like x from 1 to 15. So t from 0 to 14. So this is t, and this is negative half. So x is 1 plus t, 1 plus t dt. Okay, so that's this integration. So this integration, we also can take negative half outside. Okay, so this equal 14. The t is negative half t dt. Okay, so we don't like half t, so maybe we just also use substitution. So let's say we just t over 2 equal u, or t equal 2u. So this integration, we just check this part, so becomes this, right? So from 0 to 28, right? U equal t over 2 equal u. I'm sorry. Sorry, this equals 7, right? Yeah, when t equal 14, u equals 7 here. So then t equal 2u, and e negative u du du. So t equal to u, so 2u, 2 du. So we just simplify this equal to 4, 0 to 7, u is negative u du. So for this one, maybe we have to use integration by parts. Okay, so this become, but anyway, this is math problem. Okay. Okay, so for last question, 55. Okay, so here let's say claim, monthly claim. We just say, oh, this is something, this is x. Okay, this claim we denote as x. So have density function this, or proportional. So just like k, like we need to find this k. Okay, so we need to find expected value. Okay, so this problem is just like find expected value for x. So we just use the definition. Okay, so here is 0 to infinity. So x 0 to infinity. So x times density function. Density function is k 1 plus x negative 4. Okay. Okay, so at the first we need to find the k. So what is k? K is, let's say, k is this, right? 1 plus x negative 4, I'm sorry, k1 plus x negative 4, so x from 0 to infinity, okay, dx equal 1. So at the first, so this integration, we just the integration 1 plus x negative 4. So negative 4, 1 plus x negative 4, we can change this 1 plus x as t, right? 1 plus x equal t, so t equal 1 to infinity. So here t negative 4 dt. So t negative 4 is integrated out 1 over 3. Let's say t negative 4 integrate negative 4 t, yeah. So this equal k times 1 over 3. Yeah. So k equals 3. Okay. So now for this integration, so that's easy, right? So k is 3 times this. So okay. So here we use again we use substitution. We just let 1 plus x equal t. So this equal 1 to infinity. Right? So this x is t minus 1 times t negative 4 dt. So this equals 3. So here 1 to infinity. So here t negative 3. So t negative 3 minus t negative 4 dt. So t negative 3 we can integrate it out, right? T negative 3 I think is 1 over 2. 1 over 2, so t negative 4 1 over 3. Okay, so this equal half. Okay. Okay, so we can stop here. Okay, so see you next class or next lecture.